Today in pre-cal we learned about geometric sums. This is pretty similar to what we talked about last week when we talked about arithmetic sums, with a few differences obviously. Part A for today, a sequence is geometric if the ratio of consecutive terms, meaning the terms in order, if the ratio of consecutive terms are the same. So if I take the second term, for example, a2, and divide it by the first term, a1, and I get a number r, and then I do that again and do a3 divided by a2 and get the same r, then r is the common ratio. Okay, and if there's a common ratio, then the sequence is indeed geometric. Let's look at an example of this. Number 1, is the sequence geometric? And if so, determine the r. Okay, the sequence is 2, 4, 8, 16, and on and on and on. If I do 4 divided by 2, I would get 2. If I do 8 divided by 4, I would also get 2. So the answer is yes, r equals 2. And I could have continued on. 16 divided by 8 is also 2, and the same would be true if we saw more of the sequence. If there was not a common ratio, then the answer here would be no, and there would be no r to find. For part B, the nth term of the sequence is, and this is for a geometric sequence, a sub n is equal to a1r to the n minus 1. So if we have those pieces, we can plug those in and get an answer for these. Example number 2. Find the first 5 terms. a1 is equal to 3 and r is equal to 2. Okay, we have those two pieces. Let's plug them in. So a sub n equals, in place of a1, we're going to put 3. In place of r, we're going to put 2 to the n minus 1. Remember, n represents what term we are looking at. We already have the first term, a1, which is 3. If we're looking for term 2, we're going to do 3 times 2 to the 2 minus 1. 2 minus 1 is 1. 2 to the first power is 2. And 2 times 3 is 6. For the third term, we have 3 times 2 to the 3 minus 1. 3 minus 1 is 2. 2 squared is 4. And 4 times 3 is 12. Be careful when you're doing this that you are indeed going in order of operations. Especially if you're using your calculator, you'd want to put this piece right here in parentheses and this in parentheses as well, or you're going to get an incorrect answer. So watch out for that. You may also be able to use the fact, if you're going in sequential order, that r is 2, meaning it doubles every time. And you see that, 3, 6, 12. I could continue doing this every time, or I can just double it. The double of 12 is 24. The double of that is 48. And that's my first 5 terms. Example number 3. Find the 15th term of the geometric sequence when a1 is equal to 20 and r is equal to 1.05. Now, in this case, you would not want to have to do the r 15 times. So instead, you'd want to use the equation and just plug it in. So a sub n equals a1, which is 20, times r, which is 1.05, to the n minus 1. If I plug in 15 as my n, a sub 15 is equal to 20 times 1.05 to the 15th minus 1, which is to the 14th. And when I plug that into my calculator, you should be getting about 39.599. Again, the calculator does the order of operations that you put in, so be careful on that. If you're getting a different answer, let me know and I'll help you with your calculator. Example number 4. Find the 12th term. And the sequence is 5, 15, and 45. And that would be all that they would give you on this one. So you would need to find some information here. A1, the first term is 5. R, the common ratio, if I did 15 divided by 5, I would get 3. If I did 45 divided by 15, I would also get 3, so that's my common ratio. If I plugged those pieces in, I would get 5 times 3 to the n minus 1. And if I plug in for 12, I get 5 times 3 to the 12 minus 1. And when I put that in my calculator, I get 885,735. And that would be my answer. The assignment for this is A5. It's page 669, numbers 6 through 14 even, 27 and 28, 35 and 36. It's a pretty quick assignment if you'll just do it right after the notes. Good luck!